Hello, everyone, and welcome to today's webinar. We're just going to wait a few seconds for everyone to join us. Hello, and welcome to today's webinar hosted by Husky Technologies. Today, we will take an in-depth look at how to design and produce food and beverage packaging for the circular economy using key materials such as rPET and bioplastics. My name is Zahir Azzam. I am a regional sales manager at Husky, and I will be your host for today's webinar. I joined Husky in 2012, and I'm currently handling rigid packaging sales for the Middle East region based out of Dubai. For today's webinar, joining me is Philip Parubits, who's a business development manager at Husky. Philip has been in his current role since January 2020, based in Dubai. He joined Husky in 2006 as part of the engineering team and has held a number of technical and management roles within the rigid packaging organization. Joining us as well from Husky Luxembourg is Fabrice Becker, who has 25 years of experience in the packaging industry. Fabrice joined Husky in 2016 and holds the position of business manager, rigid packaging applications. Today, sustainability is no longer just a buzzword. By adopting circular packaging processes and solutions, producers can meet regularity requirements while also satisfying consumer demand and enhancing brand reputation. The food and beverage industry is at the forefront of innovation in this area. In today's webinar, we will explore the broader implications of the circular economy, as well as how leading brands are leveraging this opportunity to reduce costs, increase design flexibility, and boost production differentiation. In fact, lately within my region, I've noticed that during the majority of my meetings with customers, or even discussions with family and friends, the topic about sustainability always comes up. I believe this indicates the level of awareness and interest we have today in moving towards a more sustainable packaging solutions. So before I hand over to Philip, I would like to highlight that there will be 15 minutes assigned at the end of this webinar for the questions and answers session. Using the Q&A box, please submit all your questions and we can put them to our presenters at the end of the session. You can do this throughout the entire webinar, and we will do our best to answer as many questions as possible. With that, I'd like to hand over to Philip for the presentation. Philip?
Thank you, Zahir, for the kind introduction, and good afternoon, and welcome to everybody for joining this webinar on how to design and produce food and beverage packaging for the circular economy. This is, in fact, the third webinar for Husky on the topic of the circular economy. The first one was aired in Southeast Asia, and the second one a couple of weeks ago in Europe. And in both cases, we're witnessing a huge interest in the topic of sustainability, with many hundreds of people registering for these webinars and attending them, which is a reflection of the enormous importance of the topic of sustainable packaging today. The purpose of today's webinar is to share with you an overview of the many aspects and considerations of sustainable packaging, which I hope can help and guide you to achieve your sustainability goals. We have a lot to cover, so let us dive in. So today's presentation will be divided into three sections. In the first section, we'll talk about the circular economy and sustainability and where we are today. In the second part, we'll talk about how to design circular food and beverage packaging. And namely here, I'm talking about choosing the right materials, how to design the PET bottle, and lastly, closure innovations, which can help you support your sustainability goals as well. And finally, we'll wrap up with the production process to transform your PET packaging concept into reality with a production industrialized bottle. So let us first answer the following question. What is the circular economy? And here, allow me to paraphrase this quotation I got from Husky CEO John Galt, which I believe clearly and concisely summarizes what is the circular economy. And it goes as follows. The circular economy is recognizing the value of materials we are using and ensuring they are kept in the economy and out of the environment. The next question becomes, how does the circular economy relate to packaging? And here, arguably, the circular economy relates to packaging in two fundamental ways. Number one is to design your packaging for durability and recyclability. And afterwards, to set up processes to recover and recycle those resources at the end of life. In other words, packaging for the circular economy means, number one, setting up processes to ensure that the packaging is properly collected and recycled, the recycling rate, so to speak. And secondly, to design the packaging in such a way that the new packaging can be produced from recycled old packaging, the recycling content, so to speak. In fact, recycling and the circular economy is a critical enabler of the larger sustainability story for packaging, which includes reducing greenhouse gases, and here I'm talking about reducing your carbon footprint of your packaging. It also includes reducing virgin material consumption, so here I'm talking about lightweighting your packaging, and finally ensuring that the packaging is properly collected. You have zero waste on land and also marine waste, and you have zero litter. And this also includes topics like water, making sure we don't have any water waste in the production of this packaging as well. Now let us take a step back and evaluate where we are today with respect to the circular economy for packaging. And this map summarizes all the regions in the world where significant legislation regarding the circular economy have been ratified. Much of this legislation is manifesting as either extended producer responsibilities, such as EPRs in the United States, in the European Union, in Southeast Asia, and we're also seeing legislation being passed in India. And it can also manifest as container deposit schemes, like we're seeing in Australia, in some states in the United States, and some provinces in Canada, and also in a number of countries in Europe. One way or another, all of these legislations are really focused on these two metrics. Number one, like I mentioned before, increasing the recycling rate, the percentage of bottles and packaging that are returned back to the recycling. And number two, recycling content of new packaging, ensuring that new packaging is made from reconstituted, recycled post-consumer packaging. And we're seeing that over time, legislation does make a difference. It does improve both of these metrics, and therefore we expect to see that more countries will adopt legislation in the future to promote the circular economy. Now let us take a closer look at the single-use plastic legislation ratified in the European Union, which could serve as a reference to many countries around the world who are thinking about adopting circular economy legislation. So the three main points here I want to mention. Number one, the SUP legislation is mandating recycling content and rates. For example, 25% of all plastic packaging needs to constitute recycled PET packaging by the year 2025. And by the year 2030, 30% of that packaging needs to constitute recycled materials. The second aspect is a gradual phasing out of a number of single-use plastics, such as cutleries and straws and stir sticks, etc. And the third aspect of this legislation is a mandate for tethered closures. And here I'm talking about by the year 2024, this year, and really in effect next year, all plastic containers under 3 liters in size will require that the closure remains attached to the bottle even after opening. So when you recycle the bottle, it ensures that the closure comes together with the bottle. So as countries around the world are considering legislation for the circular economy, they perhaps can adopt some of these measures into their legislation as well. At the same time, while legislation is being introduced around the world across many countries, the consumer packaged good industry is not waiting. They are moving themselves with their own bold sustainability targets and investments to support the circular economy. And on this slide, we show some examples of some brand owners who are setting very ambitious targets for recycled content in new packaging, ranging from 25% to 50%, up to 100% in the upcoming years. And what is not shown here, but also equally important, a lot of these brand owners are also setting targets for recycling rates, ensuring that packaging that goes out into the market comes back for recycling. And they're also setting targets to reduce raw material consumption. And here I'm talking about lightweighting their packaging. And we're seeing these type of commitments and investments coming from all stakeholders in the consumer packaged good industry, starting from the resin producers, the plastic converters, the solutions providers, and finally the bottlers and the brand owners themselves. In the previous couple of slides, we talked about how legislation and the industry is pushing forward the circular economy. And this is the why, so to speak. And now let us talk about the how. And here we'll talk about what are the strategies and best practices available to you in designing sustainable packaging, which will A, meet legislative requirements, 2, achieve your sustainability targets, and number 3, future-proof your business. Let's take a look. When we talk about package design for circularity, we're fundamentally talking about, number 1, choosing the right material, number 2, designing for minimum waste and maximum recyclability, and finally, choosing the right production process to transform your packaging concept into reality in an industrialized real-world setting. And let's begin by talking about how to choose the right packaging materials. But before I talk about the packaging materials, allow me to say a couple of words about plastic packaging in general. And here, let me ask you to think about how much progress we made in the past 50 years. In particular, how much progress we have made in reducing extreme poverty, in reducing famine, lowering infant mortality across the world, and also eliminating or reducing disease around the world. Now, let me ask you the following question. Do you believe any of this could have been possible without plastic packaging? Plastic packaging that provides safe and affordable food, water, medicine, and hygiene products to all 8 billion people on Earth, to all 195 countries. The answer is clear. Plastic packaging is essential for human flourishing. However, it has also become clear in the past 50 years that human flourishing also means protecting our environment. And here I'm talking about addressing greenhouse gases and also creating a circular economy built around recycling. And on this point, we still have a lot of work to do. And a big part of this solution will come from using PET packaging, especially recycled PET packaging. And I will talk about this in the next couple of slides. When you take a look at the big picture, when you take a step back and you examine the total life cycle of the different types of packaging materials, PET packaging clearly stands out above the rest. Shown on this slide are just a couple of examples of different reports issued by different agencies, by different publications, showing that PET emits fewer greenhouse gases, it requires less energy to produce, it creates less solid waste, and requires less water during production. Clearly, PET stands above the rest compared to the other materials. Now let us take a closer look at the carbon footprint of PET compared to the others. PET has a lower melting temperature as a material compared to the other types of materials, which translates into a lower processing temperature, which finally corresponds to the lowest carbon footprint. What about the amount of water required during the production of these materials? If you take a look here too, PET stands above the rest in terms of requiring the lowest amount of water consumption during production. And here, let us take a closer look at the material composition of the different packages, which is a proxy for its recyclability. And here too, it is evident that PET packaging is among the leading materials for recyclability. Now, allow me to finish on this last point, which is an important point of understanding trade-offs, which is a point that's not really discussed very widely, or the consequences are not very well understood. What would be the trade-off if, for example, all 8 billion people in all 195 countries have their food, their water, and their medicine delivered with only aluminum, carton, or glass packaging? What would that world look like? In the case of aluminum, it means that 140 million additional tons of additional red mud that needs to exist on Earth for the processing of aluminum. In the case of carton, it means a 13 times increase in the rate of deforestation. In the case of glass, it means a 7-time increase in the amount of greenhouse gases emission contribution in terms of packaging. Anyone serious about sustainability will need to consider PET as the packaging material of choice. And now that we have identified PET as the most sustainable packaging material of choice, let us turn our attention to the package design. And here in this section, we'll talk about 5 design features that could help minimize waste and improve recyclability. We'll start by talking about labelless bottles, then we'll move on to recycled PET bottles, then lightweighting, and then finally on the closure section, we'll be talking about tethered closures and the new and exciting PET closures that Husky is launching. And here, let us start with labelless bottles. And like its name suggests, it means that this is a bottle without a label. And the question becomes, without a label, where do you put all that important information, such as the brand logo, the bottle barcode, and the product information? And on the example on the left, all of this information is directly engraved onto the bottle using a laser. And on the example on the right, some of this information is embossed directly onto the bottle during the blown process. And they also cleverly introduce a separate detachable carton clip to capture the rest of the information. The benefits of labelless packaging are clear. We're talking about reducing waste. There's less chance of litter without the chance of the label going onto the ground or into the waterways. There's lower raw material consumption. And most importantly, the removal of the label. It really simplifies the recycling process. Number one, sometimes the label interferes with the identification of the plastic. And also by removing the label, we're talking about reducing inks and we're talking about reducing glues as well. All of this greatly supports for a simplified recycling process. And this leads us to our next topic, which is the topic, arguably the most important one, which is the topic of recycled PET or rPET, which is the center of the circular economy. Recycled PET is unique that it can be recycled up to 100% for food grade applications, bottle to bottle, and it can be recycled continuously. And it is already being recycled everywhere around the world, up to bottle grade level. All of these points mean that recycled PET packaging is the most logical choice to build a circular economy. Given the importance of recycled PET, I believe we should spend a little bit of time understanding where recycled PET comes from and talk about some definitions and facts about recycled PET. And I think it'll be important for you to understand this when you start thinking about the challenges of using recycled PET and so forth. So we start with the PET bales or PET bags. So these PET bottles, they can be collected in a formal way. For example, municipalities collecting these PET bales, for example, what is done in Europe, or they can be collected informally by people who gather and pick up the PET bottles, as is done in South Asia. In either case, this PET feedstock is fed to the recycler. And the first step is taking this PET feedstock and inserting it into the sorting and washing step, which typically is one equipment supplier which does both the sorting and washing. And what the sorting and washing step does, it mechanically separates out the PET from many of the other types of contaminants. It usually includes a grinding step, or for sure includes a grinding step, which takes the PET bottle and grinds it into a flake. It includes a washing step where it vigorously washes the bottle. and many of the contaminants are washed out. So the output of the sorting and washing step is typically washed clear or light blue flake. And this type of feedstock is very useful in many cases. It could be used to make fibers, it could be used to make strappings, sheet, etc. But the question is this type of material feedstock suitable for bottle grade application? And the answer is no. We need one more step. And that is the decontamination step. Because these flakes still have contaminants in the middle of the flake. And that contamination, those volatiles need to be removed. And here in the decontamination step, we're using combination of heat and time to remove all of those volatiles. Secondary objective of the decontamination step is to pelletize, to convert from flake to pellet. It also is used to increase the crystallinity and the IV of the PET to make sure it is bottle grade. So the input of the decontamination step is the washed clear and light blue flake, and the output is going to be this food grade pellet. Now, it is important to note that in many cases, the shape of the pellet that comes out of the recycling step is very often spherical. And today, most of the virgin pellet is cylindrical. Both of these can be processed in the injection molding machine, but the spherical pellet is more challenging. It's more difficult to melt. So consideration needs to be considered in the configuration of the injection unit and also in setting the right process. There's some challenges associated with the spherical recycled PET pellets. And finally, this feedstock, this rPET, is fed into the injection machine to make the preform and subsequently in the blowing and filling line for the bottle and filling afterwards. And this is what we mean when we talk about PET bottle-to-bottle circularity. And here we have 100% recycled PET to produce a bottle, which comes back and is recycled, produces the PET, and so on and so forth. If you're sourcing recycled PET from a good supplier, it's quite often that you will receive a specification sheet, which will include the rPET resin IV, its crystallinity, acid aldehyde levels, the size of the chips, and the color. And we too at Husky, we also have our own specification sheet, which indicates to the user what type of rPET we recommend to be used on our machines. In many cases, perhaps because there's not enough rPET supply in the market, maybe because rPET is very expensive, or maybe because the producer is looking to ramp up rPET from a low level up until 100%. We're seeing many operators out there mix virgin PET with recycled PET, typically 25%, 30%, 50%, up to 100%. And we're also seeing operators include some colorant. It is a fact that rPET sometimes have some type of color. It could be a slightly yellowish tinge or slightly brownish tinge, and sometimes the blue colorant is added to the recipe in order to give the bottle a uniform, nice blue color. And it is even sometimes possible to fluctuate the color level on the Husky machine should the feedstock change, the color in the feedstock change, and you want to make sure that the output is uniform bottle with a uniform color. It is possible to vary the colorant level to make sure that you have a uniform preform color as your output. The story of virgin PET is also slightly more complicated. There's something to be discussed here as well. Virgin PET is itself made of different raw materials. And the source of those raw materials could be non-renewable resources, or that raw material could be used, could be made from renewable resources. And we call this bio-based PET. And you might have seen this in the market with something called plant bottle, where we are using feedstock such as corn, or it could be perhaps sugarcane, to produce one of the two raw ingredients. In some cases, up until today, up until this year, both of the raw materials, MEG and PTA, are made using bio-based resources. But regardless, whether it's just MEG or both MEG and PTA manufactured using bio-based PET, the result is still 100% PET, which is 100% recyclable. And we're also seeing a lot of interest, and we also at Husky have a lot of experience in managing, processing different types of non-PET alternatives. For example, like PLA, polypropylene, PEN, and other types of materials. We have customers out there who elect to use these type of other materials. One of the more interesting ones that we're getting some interest for is a PLA. This is a commercially biodegradable bioplastics, and we see references of this type of solution, bottles in the Middle East, we've seen bottles in Southeast Asia, in the United States using a PLA as a material. It's important to note, however, that these materials, in the perspective of the PET recycling stream, is considered as a contaminant. So care needs to be taken to make sure that these materials are separately collected and that they're composted in their own way, because in the PET recycling stream, they're considered as a contaminant. So they'll be actually flushed out, or in some cases, they need to be removed in some other way. So as we discussed before, as the sustainability benefits of PET are becoming clear, and as investments in recycling capacity continue to grow, we see that the proliferation of rPET bottles around the world in all types of consumer packaged good applications, including soft drinks, including liquid dairy products, including food applications, and also in home and personal care. And at the same time, as brand owners are electing to move towards recycled PET, they're also using the opportunity to incorporate other types of sustainability features in their packaging. And let us take a look in the next couple of slides, some examples about this. And here, let us start with bottled water. And this is where recycled PET first started in the soft drink category. And it makes sense it did that because in terms of package performance, still water is probably the easiest one. All of these examples here are examples of 100% recycled PET. And here you can see brand owners electing to include a number of other sustainability features. We see examples of labelless bottles where you see the information, for example, the logo, some information about the company, the bottle size are embossed directly onto the bottle. We're seeing Suntory incorporating that clever carton clip to put additional information. Nestle, and they elected to include a number of features. Number one, they have the tethered closure. They have a special label which uses less ink and uses less glue. And finally, we have the example of Ice River in Canada, which is an interesting story. Here, Ice River has worked together with the municipalities of Ontario and working with them to collect the PET feedstock directly from the municipality, bring it to their facility, and they do end-to-end production. They do the sorting and washing, the decontamination, injection molding, blowing, and filling. Everything under one roof. And we're seeing more of these type of collaborations around the world with bottlers looking to secure their feedstock and making sure they're able to meet their targets. The second soft drink category, which incorporates recycled PET, is in the carbonated soft drink category. Originally, there was some thinking that maybe rPET would not be able to handle the internal pressure of carbonated applications. But around 10 years ago, it's already proven that would be possible. And now we have a proliferation of recycled PET applications up to 100% for carbonated soft drinks around the world. And even in the sensitive category, here I'm talking about juices and sports drinks and ready-to-drink teas, which are aseptically filled, we're seeing recycled PET being employed here as well. And here we have some examples of some juices. We have some examples of ready-to-drink teas, all aseptically filled, a challenging process using recycled PET. Now, recycled PET is not as commonly used for the sensitive categories, but we're starting seeing more and more of it being used here. The example here on the left with Innocent, you're seeing that they're advertising that 50% of the bottles made using recycled PET. And we're seeing 15% of the bottle is using plant-based PET, which is still PET like we discussed before, but part of that PET is made from bioresources. And even if we step outside of the soft drink category and take a look at the liquid dairy category, we see examples of 100% recycled PET. And this is a particular interesting example because we see a full transformation of the packaging from Friesland Campina, where they started off with an HDPE bottle, and then they made the first step towards PET, and then they changed towards 100% recycled PET. And at the same time, they incorporated a number of other sustainability features. Number one, they lightweighted the neck. It was originally a 38 millimeter neck enclosure. Now they adopted a 32 millimeter. And also to support recycling, they have introduced a full sleeve without using glue. And there's also a serrated line on the sleeve that in that sorting and washing step, it will be very easy to break open the sleeve and so it won't contaminate the rest of the recycling process. Or even in fact, the consumer can actually do it themselves even before the bottle is recycled in the first place. A lot of innovation happening here too. So in the previous couple of slides, we talked about how legislation is mandating recycled content in packaging. We talked about how the consumer packaged good industry is making bold commitments to themselves regarding recycled content in their packaging, and how all of this has resulted in the proliferation of recycled PET bottles around the world. And all of this is pushing up the demand of recycled PET, while the supply of good quality recycled PET has not been able to keep up. So what is the result of this? It means that the cost of recycled PET is higher. And the question becomes for the bottlers, is there any way that they can offset the higher cost of recycled PET? And the answer to this question for many bottlers is to apply lightweighting to their PET packaging to offset the higher cost of recycled PET, which is our next topic. Lightweighting brings other benefits as well. By definition, lightweighting means we are reducing the raw material consumption, which by itself is also another sustainability goal for many bottlers. But before I jump into the topic of lightweighting, I think it's important to recognize that PET, as it is, pound for pound, is the most efficient rigid packaging material available. 1 gram of PET can contain up to 100 ml of liquid. For example, a 500 ml bottle weighing only 5 grams. The topic of lightweighting is important, so let us start with some basics. When we talk about lightweighting your PET packaging, we're talking about lightweighting potentially the dispensing system, which is the neck enclosure of the preform bottle. We can talk about lightweighting the bottle of the preform and the bottle, and also lightweighting the base. When you lightweight the neck enclosure, there are 2 ways you can do it. You can keep your existing neck enclosure design, but remove some non-functional material. That's one way to do it. The second way is to completely change out your neck enclosure to a new lightweight design. When it comes to body lightweighting, we can remove quite a bit of material from the preform and bottled body, but we need to keep in mind that as we remove material from the bottled body, we have to keep in mind that we have sufficient mechanical performance of the bottle. It might impact the shelf life. For example, if you have a carbonated soft drink and you want to keep the carbonation inside, that could be impacted by body lightweighting. And finally, we have to make sure the bottle is blowable from preform to bottle, and removing PET from the body could impact it as well. We need to keep that in mind. And finally, in some cases, we're seeing that bottlers are electing to base lightweighting, removing a little bit of PET from the preform base, which manifests as lightweighting in the bottle base. And let's go through an example to illustrate this point. This is an actual example with one of our customers. They had a 500 ml bottle weighing 21 grams, and they were deploying with that bottle a PCO 1881 neck enclosure. And here we reduced the neck, and in fact, we converted the PCO 1881 neck enclosure to GMB 3040, which is the latest standard for soft drinks. And this was able to achieve 0.5 grams in HDPE resin savings in the closure. At the same time, neck lightweighting, body lightweighting, and base lightweighting were all implemented to achieve around 2.1 grams in PET savings in the preform body. So what does this mean? Well, it means that for starters, we removed in this particular application with these production volumes 160 metric tons from HDPE, 830 tons for PET, for approximately 1,000 metric tons of plastic was removed. And this also corresponds to around $1.3 million in cost savings. which in this case, the bottler can use to sponsor the higher cost of recycled PET. And lastly, it should be mentioned, when we're reducing the material quantity in the packaging, we have a corresponding reduction in the carbon footprint of the packaging. Here we're talking about nearly 2,000 metric tons per year of carbon footprint savings here. And the cost savings of $1.3 million in this particular case should not come as a surprise, because it's clear that resin is the largest single contributor to the production cost of the preform production, and those savings carry on to the bottle and blowing and filling afterwards. So applying lightweighting can bring many benefits, the manifold benefits. We're talking about cost savings, which can be used to sponsor the higher cost of recycled PET. We're talking about achieving your sustainability targets and reducing your raw material consumption, and also reducing your carbon footprint. So far, we talked about labelless bottles. We talked about bottles made of recycled PET. And finally, we talked about the benefits of lightweighting bottles. But we can't complete our discussion about PET packaging without talking about closures that are used to seal the bottle. So let's talk about that next. And here, let us continue our previous discussion about lightweighting and apply it with closures. And we'll particularly discuss the latest trends we are seeing with neck enclosure designs. And let's start with bottled water. Today, the most lightweight neck enclosure combination is the 2522. And we see many water bottlers around the world seriously considering this solution to help them meet their sustainability goal. It's a super lightweight neck, even lighter closure. We have an array of designs, some with tethered closures, some of these closures slightly taller for a more comfortable grip, different designs for different type of consumer experiences. And we're working with many bottlers around the world to deploy this solution. Secondly, on the CSD front, like I mentioned before, the main trend is to convert from PCU 1881 to 2622 CSD. And the main manifestation is GME 3040. This is the trend that we see today all around the world. And here too, we have different designs, different type of tethering solutions to meet the different type of consumer experiences desired by the brand owners. And finally, on the sensitive application, like we discussed with freestyle campaign in the previous slide, today the standard for most aseptic packaging is 38 millimeters, and the lightweighting trend is to move from that to the 32 millimeter solution. And arguably the most important of these trends is the trend moving from 1881 to GME 3040 today. This is the trend that we're seeing for sparkling beverages around the world. In fact, it's really taking off this year. We're seeing investments already committed to have GME 3040 to replace 1881 in more than 40 markets around the world. And the benefits, and it's clear why they're doing that. You can clearly see that the resin savings are quite clear, both on the neck enclosure side. Here in this example here, we have nearly 1.7 grams in resin savings. And when we're talking about lightweighting the neck enclosure, we're talking about keeping the same bottle and potentially keeping the same base. We're not impacting the bottle performance. We're not impacting shelf life here. We're not impacting blowability. And as bottlers around the world are converting from an old neck standard to a new neck standard, they're sometimes using this opportunity to also launch a tethered closure, which is the next topic. And here's an example of a tethered closure for GME 3040. It has the same weight as the tethered ready version showed in the previous slide. And in fact, Husky has multiple versions of GME 30 with different types of opening angles and different types of features to offer different types of consumer experiences. And to summarize about tethering, tethering is an opportunity to number one, promote sustainability messaging centered around reducing waste and to reduce litter, making sure that all the material is returned back to the recycler as the closure remains attached to the bottle. And also offers an opportunity to provide premium package solution into the market. A well-designed and well-manufactured tethered closure can be quite attractive and quite convenient for the consumer. What's important here, it needs to be well-designed, and it needs to be well manufactured over time, that the performance of the tethered closure must be very good. And when that's done well, we've seen that consumers are actually quite keen on using tethered closures. In fact, for these reasons, we're seeing tethered closures being deployed in many places around the world, and in particular in Southeast Asia, and not just in those countries which are deploying, or rather mandating them, such as the European Union. And finally, let us talk about ostensibly and arguably our most exciting innovation, which is the PET closure, which we have just introduced this year. And the PET closure opens up many possibilities. With the PET closure, we can achieve 100% recyclable package, our most recyclable package ever. We can potentially increase the PET bale yields by up to 10%, which will improve recycling for our recycling partners. And we open the door to incorporate rPET in our closure. More news about PET closure will be upcoming in the rest of this year. This is a very exciting innovation. We have a lot of discussions with many bottlers and plastic converters around the world on this topic. We expect this to be a game changer. And finally, up until now, we talked about the PET packaging materials. We also talked about PET packaging design, including the labelless bottles. We talked about rPET. We talked about lightweighting your bottle. We talked about tethered closures and PET closures. However, to transform an idea, a concept into reality, you also need the right technology and you need the right partner. And here I'm reminded by this quotation from Elon Musk, stating that manufacturing is insanely difficult. It's easy to design, it's easy to make a prototype, but to industrialize it at a consumer level, at an industrialized level, is very challenging. And this is where Husky can come in. We can support you in achieving your sustainability goal. And it starts by having the best equipment to do the job. And here, I'm illustrating here the Husky's rPET ready solution, which is equipped with the latest technologies and is optimized to run and process recycled PET every step of the way, starting from the resin preparation and drying, then to the melt delivery system. And here I'm talking about the right customized screw, talking about the injection unit and the optimized hot runner, then to preform production in the mold, then afterwards, downstream processing and closed loop quality monitoring. And finally, we have our team of rPET process experts and rPET services here to support you with introducing new rPET materials into your operations. And stepping beyond the hardware, each Husky machine is now equipped, is now integrated with our new and latest and greatest Advantage Plus Elite program. And here with Advantage Plus Elite, you get real-time monitoring of your system variables 24/7, hours a day, 7 days a week. And our team will call you proactively if we identify some potential risks or issues in your system, and we'll work out and to make solutions together with your team. Advantage Plus Elite is particularly valuable when running recycled PET, given all the variability that are associated with recycled PET. And even stepping beyond the system, Husky can even support you on the design and optimization of your facility, and specifically optimize it to reduce energy consumption and to optimize it for running recycled PET. All of this comes together with a recently introduced Husky Complete system, a Husky Complete solution, and here we provide end-to-end support, starting from the application development and advisory services at one end to make sure that we are enabled to set you up for success, right to the end to Advantage Plus Elite to make sure that success is maintained afterwards. And this concludes my presentation. So I'd like to thank you all for joining me as we explore the different facets of sustainable packaging. Please, if you have any questions or you wish to learn more, please feel free to contact me directly or connect via Husky through the QR code. Now I'd like to hand it over back to you, Zahir, for the question period.
So thank you, Philip, for a very interesting presentation. Indeed, it's an eye-opener on the value drivers of PET as one of the best sustainable packaging material. Thank you to all our attendees for your attention so far. Now we're going to move to the Q&A session. We've already had some great questions coming through. Please continue to send them as we go through some of those questions. I would like to highlight here that if we don't manage to get through all of your questions, don't worry. The team will follow up with you individually after the session. So for the first question I have here, a very interesting question. What is the cost benefit of rPET over PLA and other materials?
Okay, yes, that's more a question about all these alternative materials. I would say in regards to PET or recycled PET. So when I say alternative materials, it's a lot of biosourced materials or biodegradable, compostable. So you have PLA, you have PHA, you have PEF, PEN, PVOH, you have quite a lot of materials. The problem of all these materials is that you don't have a lot of supply. I mean, the supplier don't produce a lot of amount of this resin. So for sure you can use them, but the price is very, very high because of the shortage of the material by itself. It is used in other industries, not a lot in beverage. But recycled PET, so if we compare the price, PET price in general now, it's between $1,000 to $1,400. It depends on the area in the world. With recycled PET in the US, it's very cheap compared to the other area because they have a lot of recycling stations. So it's around 1,700. And recycled PET in Europe, it's 2,000, yes, $2,000. So what I would like to say is that PLA, I have no price really about it. I know that we made some trials, some customer made some bottles. So we had some how to say feasibility test and so on. And so we know the price that customer bought and so on. So it's very high. It's something like 3,000 and even more dollars. So
Wow.
it has to be only for small marketing campaign, this kind of bottles, because it's very, how to say, regarding marketing, when you make a PLA bottle, it makes, yes, you have a nice image of your company when you make it on internet and so on. So I think in your region, Zaire, you have Alaina, they made in
Correct.
PLA, I think, yes. So we have some in the US, in Europe, but it was only for short, small marketing campaigns, in fact. And PLA cannot be mixed in the PET stream because you have black specks. So you have to put that on the landfill. You cannot put that in the recycling stream afterwards. And it's difficult to identify them in a sorting area as well.
Thank you,
So that's why
Fabrice.
that was a good question, yes.
Yeah. In fact, yes, I see through also the comments and this talking about the availability of those non-PET like biodegradable resins as well being difficult to get a hands on. So, which is an indication of why the high prices. The next question I have here is talking about: is it possible for small and medium producers of water with monoblocks to utilize recycled PET bottles?
Um, so here, in fact, for water, for sure, recycled PET, it's a good solution because we have so many customers in water business. They already fill in recycled PET. They all started in water business because it was easier at that time to do it with, regarding the bottle performance of a water one compared to a CSD one, you don't have that much pressure and so on. So 6 years ago, everybody started to produce this bottle in recycled PET. When you have a look, for example, the first one that started, it was Danone, Nestle, and then I think in Europe and in the US, there are a lot of brands with recycled PET in water. So in Europe, for example, it's going to be mandatory next year, 25% of amount in a PET bottle. Maybe the question is in two ways, because maybe it's not only linked to the water segment, it's linked also with the monoblocks. But the monoblocks, I don't know what the person means about the monoblock. It means a combi, blower, filler together, maybe a monoblock like this. So here, for sure, I don't see any issue at all, because the blower is a blower and you can put it with a filler. It doesn't matter. especially for water, because you have no burst, no creeping on the bottle base. So with recycled PET, it goes very well. No problem at all.
Great, thank you again, Fabrice. I have another question here. Someone asking about the nomenclature of GME 3040. Why is it named GME 3040 for that neck finish?
Yes, that's a good question because in fact, so these neck finishes are validated at SETI. SETI is an organization in Europe. SETI, at SETI, you have many attendees from many brands, big brands, Coke, Pepsi, Nestle, and so on, a lot of brands, and also from the main suppliers, closure and equipment suppliers. So Husky is at SETI. By the way, Sylvain Talarico is the president of SETI. He's a Husky employee and is general manager Europe. And in fact, all these name, I mean, it's a name to be validated. So, for example, for this 20, because GME 3040 is linked to the 2622 neck finish, the new one that is replacing the 1881, PCO 1881. So this 2622, in fact, you have many different versions. And I'm sorry, I'm going to be maybe heavy, but you have the GME 3037, 3041, and this 3040. So for sure, all these denomination, it doesn't mean anything to how to say to the customers. It's only a registration number at SETI. And with this drawing number, with the denomination, when you go on the internet on SETI site, you can find then all the details about the neck. You will see that it's a 2622 with a neck height, different dimensions, support ledge dimension, e-wall dimension. So you are going to have all these dimensions by typing this denomination on SETI site.
And maybe I can just add here, when you say 26, 22, the 26 correspond to the thread diameter, the thread to thread diameter, and the 22 corresponds to the IBD diameter, which is the whole of the neck. GME 3040 and all those number designations, as Fabrice said, they're actually probably released in chronological order. There's no link, chronological order. They're not linked to the geometry anyway. 26, 22, those numbers mean something in terms of geometry. GME 3040 is just a sequential number.
All right, great. Thank you, Fabrice and Philip. One question came up from Haswin Kumar. He's asking about the sorting process, if we are able to segregate by color the bottles.
Yes. So when we are talking about sorting lines, so now in the world there are so many different, suppliers of I would say mechanical recycling, different equipment, and especially at the sorting area. If you compare a price of a recycling station in Europe and a station in Japan, the Japanese is twice as much higher in price. Why? Because they have much more equipment to sort, to select, how to say, the different plastics, to separate from the labels and so on. So sorting, for sure, you want to sort each different market segment. Water from a CSD. Also, it's better to separate it by color, because as soon as you have a lot of color, then for sure the recycled PET is affected by its color by itself. So what we see in Japan is that the sorting lines select very well all these colors and so on, opaque and so on, and they have a recycled PET grade that is very, very close to the virgin one, even the same, because when you have a look, all the bottles are very transparent. This, we could not achieve that in Europe and in the US, because the sorting equipment have to be, how to say, the recyclers, they have to buy more equipment to separate. So for sure they do it, they learn a lot, but the best, yes, it's to sort, and it's possible. So to answer to the question, yes, for sure, it's possible with all the cameras and so on. And even what we see and what is very nice now is the artificial intelligence, because with this, we capitalize the information, and we don't need operator to detect something that has went through without being detected. So this is the next level, and at one point, this artificial intelligence will help quite a lot. Hello?
Sorry, Fabrice. So I have another question that came up about our very exciting project, the PET closure. So Jude is asking if our PET closure, is it injection molded or compression molded? And if I maybe add a little bit, maybe if we can touch base on the different, not the difference, but maybe the advantages of injection molded closures, Fabrice.
Yes. So this PET closure, yes, is injection molded. And we started to design this PET closure, it was 4 years ago. So we learned quite a lot of details, information, you know, we made many trials. We started this, PET closure with a certain grade of PET at that time. It was interesting because it's a level that is not as high as the PET bottle. So we started at a 0.5 IV, something like this. And then now at NPE, when we were last month, in May at NPE, we showed all the PET closure with a IV of 0.75, 0.8. So the same, absolutely the same IV as a PET bottle. So that's why we say it goes now to the same recycling stream without altering the quality of the recycled PET, especially the IV level, because you want to boost the IV to reach a higher level than 0.8. So injection molding, yes, it is done like this. This is Husky technology. And we prefer this technology. Why? Because we showed as well all these tethered closure with PET closure. So we make PET closure standard and also with tethering, with the hinge. And by compression, I don't think that it's possible at all to slit the PET closure. It's the PET is too stiff compared to HDPE, so the knife will not stain a lot of time. So this injection molding technology allows both PET closure to be standard and tethered.
All right, great. I have a question coming up from John. He's asking if we see any markets using, I believe he's talking about rPET, but in beer application.
So beer application in PET. So it's a lot about Central Europe, Romania, Bulgaria, also Ukraine, and Russia a lot as well. The volume are 1 liter, 1.3 liter. In the world in general, so we don't have a lot of, I would say in the US there are some bottles, but not that much. In Europe, I know that in Romania and in Austria as well, they use recycled PET, but here what is important is it depends on the process that is used. If it's flash pasteurizer or tunnel pasteurizer. So flash pasteurizer is when you decontaminate the beer in a flash pasteurizer and you fill it at 4 or 8 degrees, then recycled PET is absolutely perfect. There is no issue with the bottle performance. On the other way, if you use a tunnel pasteurizer that is, I don't know, 65 degrees at 15 minutes or 20 minutes, I think you cannot reach a 100% recycled PET bottle. You have to start like we have in Hotfield with 25%. So we make more and more progress. As I said, we started with water, then with CSD. Juices and so on, you have a lot of recycled PET bottle, but for sure for beer, as well as you have a heat set or a heat treatment directly on the container, the percentage of recycled PET, I don't recommend over 25% right now.
Okay.
It has to be improved in the future.
All right. I see we have a lot of questions coming in. I'll take one more question again about our PET cap. So someone is asking about have we already made this PET cap or is it still under development?
I cannot say the name of the early adopter on the market
Yeah.
because
Okay.
for sure after NP and before NP we had already some. What I can say is that for water application, we made all the bottle performance drop test and so on, and it's working exactly like a HDPE closure. So there is no difference. For sure, the next step is CSD application with high pressure. But can you
Okay.
imagine already with water? Water represents 300 billion units in the world. This is
Absolutely.
half of the PET beverage consumption in the world. So if you start with this huge amount with PET closure in the PET stream, it's a huge amount of bottle already.
I agree. All right, so that's all the time we have for today. I would like to thank everyone for joining us. This webinar will be available on demand within the next couple of days. You will be sent a link to access it in case you want to recap on anything you've seen in today's session. That just leaves me to thank our speakers, Philip Perovitz and Fabrice Becker. And thank you everybody for watching. Thank you very much and have yourself a great day ahead.
Thank you. Bye-bye.
Bye-bye.
Bye-bye.